Welcome to the channel guys, and today we will see what is the procedure of performing molecular dynamic simulations for our system. Okay, so there are some steps that we go through when we perform molecular dynamic simulation. So first step is the minimization, and after that it is heating of the system, then equilibration, NBT equilibration, then NPT equilibration, and the last step is the production run. So one by one we are going to discuss these steps. Okay, so let us start with the minimization. So what is minimization? Minimization remove any bad contacts between the atoms. Okay. So the system reaches to the minimum possible energy configuration. So it is like this. So let us consider that I have a box of atoms. Okay. So I want to simulate a system. So these are the atoms that initially uh, uh, randomly packed inside this box. Okay, they are packed randomly inside this box. So now they are randomly packed, so there can be some bad contacts between the atoms. There can be some bad contacts between the atom, and the initial energy of the system may be high. Okay, initial energy of the system may be high. So to start the molecular dynamic simulation for this system, we have to reach or optimize this system to the minimum possible energy. Okay, so we can get a decent initial configuration for our next step. Okay, and what happens during minimization? The temperature of the system reaches to near absolute 0 Kelvin. Okay, so when we perform minimization, so after minimization the system is at 0 Kelvin temperature. Okay, so now the system is at 0 Kelvin temperature and minimization has been done. So the system is at minimum possible energy. Okay, minimum system has reached a state where it is at its minimum possible energy. Okay, so after that there is heating of the system. So what we do, we slowly heat the system from 0 Kelvin to desired temperature. So let us say that you want to simulate the system at room temperature. Okay, so now you have performed minimization. So the atoms inside your system have some initial position. Okay, so now what, we are at 0 Kelvin and we want to perform simulation at 300 Kelvin, or we want to check our system at 300 Kelvin how it is performing. So you cannot directly start the heating. I mean, the if we go to next step like NBT equilibration, so you cannot directly start at 300 Kelvin. From 0 to 300 Kelvin you directly cannot start. Okay, so what you can do is you can do step heating. Okay, so like for every 1000 steps you can increase the temperature by let us say 1 Kelvin. Okay, let us say 1 Kelvin. So that's how you have to reach this temperature 300 Kelvin. Otherwise, running directly at the desired temperature, or let us say that 300 Kelvin, could leads to explosion of the frozen atoms, because initially the system is at 0 Kelvin. Okay, so it's like if you have a dry ice, and what would happen if you put the dry ice on a hot frying pan? You can imagine what could happen. Okay, so to avoid this we do step heating. Okay, so after heating the system to 300 Kelvin, we are going to perform NBT equilibration. Okay, so we will perform a small NBT equilibration to check for the pressure fluctuation. So NBT is basically, N is for number of particles and V is for volume of the system. Okay, N is number of particles, V is volume of the system, and T is temperature. Okay, T is the temperature. So we are going to perform NBT equilibration. So we are going to check for the pressure fluctuation. Okay, so let us say that if your pressure is positive, okay, if your pressure is positive or it is very high, so if your pressure is very high, you need to uh, increase size of the system. Size of the system. If pressure is very high, you need to increase size of the system. Or if pressure is very low, I mean pressure is negative, so you need to decrease size of the system. Size of the system. Okay, because we are, what we are doing in MD simulation, we are studying the reality. Okay, we are studying reality in virtual manner. So NPT is basically closer to reality. When we run NPT equilibration, it is, NPT is basically closer to reality. Okay, so if we are performing, so in reality we have pressure is 1 atmospheric and temperature is 300 Kelvin. Okay, so we need to set the system, we need to set a descent in initial configuration for our production run, where the system is at 1 atmospheric pressure, 300 Kelvin, and volume is constant. Okay, and volume is constant. Got it? So that's why we do NBT equilibration, or otherwise we can perform a small NPT equilibration. Okay, so what is NPT equilibration? N is for number of particles, and P is the pressure, and T is temperature. Okay, and T is temperature. So here number of particles, pressure, and temperature are going to remain constant. In NBT, volume, number of particles, and temperature is constant. In NPT, number of particles, pressure, and temperature is constant. So before running the production run, we can perform a small NPT equilibration. Okay, so that the box size can be automatically adjusted. Okay, so here so the volume will fluctuate, and volume will fluctuate. So the volume will fluctuate, and we will have the correct density of the system for production run. Okay, so what we want is a descent initial configuration for the production run, where uh, the pressure is 1 atmospheric, temperature is 300 Kelvin, and volume is constant. Okay, so that's why we do a small NPT equilibration. Okay, and after that we have the final step in molecular dynamics simulation. Okay, this is the final step, production run. So we prefer basically NPT run because it is closer to reality. It is closer to reality. Okay, so but some people prefer NBT over NPT because it is fast, and they argue that once equilibrated, the volume will not change much. Okay, so in the previous step, if we perform a small NPT equilibration so that the volume is constant, then the production run can be, we can perform production and NBT production run. Okay, so because the volume is not going to change too much, and it is also faster than NPT, or so it's all up to you that you want to use NPT or NBT. But it's, people prefer to go for NPT because it is more closer to reality. Okay, so that's all for today. Thank you.